Thank you everyone for coming. Super exciting to see the energy today in this event. I know deep learning AI has done so much for educating the community at large. So awesome to see the energy here as people are kind of just talking about what they're going to be building in the next frontier of AI. So just a brief overview of what we're going to be talking about today. We will be covering an overview of our developer platform, some of the newer features such as the Claude Agent SDK, some of the new advancements in our most recent models. And I'll just say that in a lot of these different topics we're going to be covering today, we could easily spend 30 minutes on just a single one, right? So we're going to try to give a broad overview of our offerings, and hopefully you all come away learning something you didn't know about Claude and our products before. So before we jump into things, I'll give a quick introduction. My name's Tanveer. I'm part of the Applied AI team here at Anthropic. So I spend most of my time working with some of our most strategic customers who are building stuff on top of our models and our infrastructure, specifically focusing in the healthcare life sciences domain. And separately, do some also internal product research work to improve our models at the domains we care about, and other product launches such as our memory system in Claude AI or the MCP registry.
Hi, everybody. My name is Utkarsh. I work in infrastructure at Anthropic, supporting both the product and research sides of the company. So let's get started. To kick us off, I want to take you all through the suite of products that Anthropic offers to give you a quick kind of summary of things. And I'm going to present this in the form of a stack because I think that's the most intuitive way to think about it. At the bottom layer, obviously, is what Anthropic focuses on a lot, which is the models. You guys all know that we have three classes of models. We have Haiku, Sonnet, and Opus. Haiku being kind of like our most cost-efficient models, Opus being the top of the line, our biggest and most intelligent model, and Sonnet being kind of like your day-to-day workhorse where we really try to strike a balance between intelligence and cost. But the models by themselves, the intelligence by itself is not useful unless we build things and products to bring them to the users, to the world. And that's where we step into the upper layers of the stack. So one layer above is kind of where we try to build the kind of capabilities that can be used to build agentic applications more easily. So these are things like memory that lets multiple conversations basically share the same context. These are things like web search, research, and orchestration that basically lets Claude do more complicated tasks or have multiple sub-agents kind of working in parallel towards a single goal. And then finally, on top of that is where we have the Anthropic's top-level platform, which are things like Claude Code, Claude AI, you guys all know these, and then the Claude Developer Platform, which is what we are going to be spending most of our time on today. This is what you guys build on top of to build your own applications. And in the next slide, I'm going to take you through the roadmap for the developer platform. And actually, let me go back for a second and make a quick call out that we partner very deeply with AWS and Google. So if any of you guys have your applications or services deployed in those clouds, then you can use Claude's APIs via Bedrock and Vertex in addition to Claude's first-party API, obviously. So speaking of Claude Developer Platform, I kind of want to take you guys through the roadmap that we have here. And we can really break it down into three sections. The first one is obviously enable all of you to build the best applications on top of Claude. And this is our big impetus to build the features that I talked about before, like memory, orchestration, web search, and such. The next thing here is basically giving Claude access to information and knowledge in your own domain. You guys all know that Anthropic invented MCP, Model Control Protocol, and that is a huge part of our strategy in this area. We want Claude to be most helpful in the context of your own applications. And then finally, I want to call out that we want to make building agents and using AI intelligence more cost efficient and faster. And this is where prompt caching comes in. You guys all know that with prompt caching, you can basically have a new prompt chain kind of resume from the context that was built up in a previous prompt chain if you're having a similar conversation with Claude as before. So it basically lets you kind of skip the time and tokens that were used to get to that context, saving you both time and money. I want to take you guys through some of the new capabilities that we have released in the Claude developer platform recently. There are so many of them, I cannot go through all of them, but I want to kind of talk about some key ones. First of all, MCP connector, which basically lets you use MCP without having to explicitly build an MCP client. So you can kind of just say in the context of a single message to Claude, tell it to use an MCP server, and we'll just do it in the background for you. The next two things I want to call out are the new Files API and our code execution tool. And those two really go hand in hand really well. Files API basically lets you upload files and then have multiple conversations with Claude, reference those files so that you don't have to upload and tell Claude that context every single time in a new conversation. And our code execution tool that basically lets Claude do more complicated analysis on any given piece of data. This could be a file that you uploaded using the Files API and generate new files. So for example, you could upload a CSV file and have Claude perform some complicated analysis and build some charts out of it, maybe even build a presentation out of it. And in addition to that, you can have Claude execute code in a sandbox environment. So these are kind of really what make Claude more powerful to do things in the real world.
Next. Yeah. And that was the suite of the developer platform, which we'll return to in a second. Now I'll focus a little bit more on some of the core research that actually goes into making Claude models great. So I wanted to really focus specifically on our recent model we launched, Sonnet 4.5, which is our most intelligent model to date, mostly highlighting just like specific areas in which we found massive improvements from the last generation of Claude models. And we hope this will be sort of telling as far as like what is on our mind in terms of research roadmap, where the models are heading, et cetera. So a lot of these sort of same advancements we're going to be talking about today, should expect those sorts of capabilities to continue to improve in future releases of Claude models as well. So I like to break it down into 4 different categories, albeit like the different advancements we make with from one generation to another can cover more than just these 4. So these are just the 4 we'll be focusing on today. So we'll start with code generation. It's no secret, if you guys are familiar with Claude and Anthropic's products, we're mostly well known for our lead in building the most intelligent, capable agentic coding models, right? If you use Claude Code before, or products like Cursor, Windsurf, or others, Claude is basically the go-to model for a lot of developers writing code in their day-to-day. And part of this is like shown in some of our like leading Sweetbench scores of 80+%. A lot of people also like look at these sorts of increases of 2 to 3% between models and are kind of asking like, why does this matter, right? I think Sweetbench in particular is an interesting eval where the actual metric range is actually like logarithmically scaled. So as you get closer and closer to 100%, even a 1% jump is actually a substantially larger jump than like maybe 5% at a lower end of the spectrum. So that's like one thing interesting to highlight. But the second is like, if you also think about all the different types of capabilities that go into making a good autonomous software engineer, it's not just about being able to read and understand and write code. It's also about other very tangible things that you as a software engineer might do in your day-to-day, right? Being able to come up with a great PRD or plan for what you actually want to implement. How do you actually like keep track of what you're working on over a very, very long coding task that requires changes to many, many different files? How do you actually like reason well, such that if you make a wrong architectural decision, you can actually reflect on that and course correct yourself, right? There are all these different sorts of capabilities across reason, context understanding, instruction following, et cetera, that kind of come together to form Claude's superiority in coding. So the big point here is that we see ourselves as like the best model for building agents, period, because it's sometimes not obvious how sometimes our superiority in coding can actually translate to building agents in so many other different domains, which we're really, really excited about. One example is how you can think about even the role of code generation beyond just software development, developer productivity, right? Many of you guys have been building agents in the sort of world that exists on the left here, in this sort of vanilla tool calling world. So in this example, you have an agent where you task it to adjust some financial model based on the latest earnings and internal projections it might have access to, right? So you might have some MCP servers hooked up to it, and what's going to happen is the model is going to make a bunch of tool calls sequentially to gather the context it needs and take the actions that it requires, right? Versus, as these models get more and more capable, especially with code and tools like Bash, et cetera, we're really, really excited about this world where you can just continue to orchestrate tools through code instead, right? Now, why is this so powerful? It means that the models can kind of follow their own patterns when completing tasks, closer to almost how a human would operate. Let's say you're a data scientist, right, operating in a Jupyter notebook or an RStudio workbench, et cetera. Your process for typically working on a new task is going to be load in some data, print out a bunch of summary statistics, create visualizations, look at those charts, right, and iterate. So you're allowing the model to basically have access to the sort of same reasoning capabilities that you almost as a software engineer or as a data scientist might have yourself. And another way I like to frame it, right, is in the vanilla tool calling world, your capabilities kind of scale linearly for your agents for every tool you add, versus in the actual world where you're orchestrating these tools through code, your capabilities scale exponentially, right? Because you have access to do so much more with a computer through code, even through the access to the different packages you might give Claude as well. Next, we'll talk about longer trajectories. Now, what do we mean by longer trajectories? We've been recently seeing that as these models get more intelligent, right, they can actually kind of work for longer on more complex tasks, right? Similar reason as to why I mentioned our lead in coding, right? It's a summation of all these different capabilities coming together to form this. But most recently, we've been seeing Sonnet 4 or 5 being reported by our customers to be able to code for 30 hours straight on building full stack applications, versus what was recorded to be 7 hours by one of our customers back in May. And I think the one capability that's really worth highlighting and digging into that unlocks this is memory, which has become a huge focus of ours at Anthropic. We believe that memory truly is what's going to unlock the sort of idea of infinite context. How do you let the model basically search for what it needs at any given point in time to read the right context in? So the simplest form of memory can be that you just give the model access to some file system. And then as it works on a task, it's able to just note down the most important details for future instances of that same agent. And then it's also able to dynamically query and read that unstructured data in that file system to actually find the right context it needs for a given task at any given point in time. So we found that recent models such as Sonnet 4 or 5 have gotten better in both axes of how do you actually use and utilize memory. Now, a more tangible example that you guys might be more familiar with is Claude Plays Pokemon. So how many of you have seen the Twitch stream or are familiar with the project? Okay, a couple of hands. So if you're not familiar, you can just go to twitch.tv/ClaudePlaysPokemon. You can literally see a live stream running where you can actually see our models playing Pokemon with the transcripts going live. But one of the cool things about this eval is one, it started out as a side project by one of our engineers, just for fun. But we've actually learned so much about our models from just how it plays Pokemon, which has been really, really fascinating to see that sort of feedback loop to research. So one example here would be models before Claude 4 models would typically actually play a game of Pokemon Fire Red, and it would basically create a monster single markdown file that contains all of its notes as it's progressing through the game for hours on end. Versus, since Claude 4 models came out, we've started to see that the model, with minimal prompting, has started to maintain a better structure of its memories, right? So it creates a single markdown file for each town it traverses, each Pokemon gym, each puzzle, each even route that it's going through, right? And that's the model just having a better sense of how do I structure my memory optimally for future instances of myself that it's able to do relatively unprompted, which is really, really cool to see.
The next thing I want to call out here is computer use. So one of the areas in which we see Sonnet 4.5 having a large improvement from any of our previous models is actually computer use. What do I mean by that? It's basically anything that humans might do to interface with the computer. So something like take a screenshot, understand it, see what's on the screen, click around, actually use a web browser, basically effect any kind of actions onto a computer. And the reason I want to call this out is because it goes to show that Claude doesn't only have strength in basically being able to understand the context that's given to it, but actually go out in the world and do useful things. And the last thing here is domain intelligence. So, we've already talked about Claude's strengths in coding, computer use, knowledge, and search, but some other areas that we see Claude becoming more and more useful for is things like financial domains, cybersecurity, and this is an area in which we continue to make improvements and are focusing on a lot. One of the things some of you might have seen is Claude for Life Sciences released recently. That's an example of this, and we plan to continue releasing more.
Sweet. Awesome. So now we'll talk a little bit more about building agentic products, right? I think we at Anthropic, for the better part of the last 2 years, have been working with so many different companies and founders, et cetera, from a variety of different domains, everything from coding startups like Lovable to manufacturing life sciences companies like Novo Nordisk and so many others, right? So we've seen a lot of people building agents successfully and unsuccessfully. So we're kind of going to just try to distill some best practices, patterns that we've observed, and hopefully that will be helpful in telling to you as you guys are going off to build your own products as well. So just to start, I'll just do a broad definition of how we think about the agents writ large, just because I think it's always helpful for us to be operating on the same set of shared vocabulary. So I would say back when GPT-3.5 came out, GPT-4 came out, most people were building things on top of these models that we would call workflows. This is the concept where you give the LLM access to some tools where it could go query some data, or it could make some write access type call to an external system to do something. And then what happens is you would chain LLMs and tools in some predefined paths. And that would basically create a workflow. And workflows can follow all sorts of different patterns, everything from chaining 5 different prompts together, or you classify an input and then send it to 1 of 5 prompts, et cetera. And workflows were really, really powerful, and still are, by the way, because it was pretty awesome how you could just take a business process that you really wanted to optimize, right? And effectively turn it into English language and prompts and kind of orchestrate it and optimize it much easier. And now since Claude Sonnet 3.5 came out, I think we started to see the emergence of agents. Agents are the idea that you give a model a set of tools, and it's able to just use those tools in a loop with some feedback from the environment it's getting. And it can take any number of steps that it itself autonomously decides to actually complete a task. So a way you can think about it is workflows are following always what is a predefined, relatively deterministic path, versus agents, you're letting the model decide what is the optimal path it should take to solve a problem. So you're really kind of leaning on the actual intelligence of the model to actually get the task that you want done. You can almost think of it like agents are LLMs with agency. And to break it down even further, I love to just break down how agents work in this concept of the agentic loop. The idea being you give an agent a task, it's going to reason about that task and build a plan of how to solve it, right? And then it's going to take that plan and start to actually take the concrete set of actions it needs to carry it out. And that will be in the form of making tool calls. And those tool calls can be querying some data, reading in some unstructured context. It can be making some critical API call to an external system to complete a task, et cetera. And then the model is going to receive the results of those tool calls, right? See, did it get the information it needed? Did it do something wrong, et cetera? And then the models are able to kind of reflect on the feedback that it's getting from those external systems to then figure out what is the next step, repeating that next part of the loop. Now, before moving on, I think one thing that's always worth calling out is a lot of people design their agentic harnesses and their tools with the full purpose or with the idea of optimizing for this bucket or pillar of action more than anything else. But I think a lot of people also don't prioritize how do you build agents in a way such that they get the right feedback they need to reflect and self-correct themselves, right? So if you think about it, let's say you're working in front-end development, right? If you are using Claude Code for front-end development, it's still a pretty powerful tool, right? But it could spend like 20 minutes building you a React app, and then you open it up, and like the style is not great, or like the layout could be like wrong, et cetera. So in that sort of scenario, how do you actually give the model the right context or the right feedback it needs to like self-correct itself? And that would be like basically giving it some mechanism or MCP server in which you can look at the browser, take screenshots, identify some issues in its layout, and then correct its code, right? And we also think that's like one of the biggest unlocks for how do you actually build agents that can work for longer on more complex tasks.
So we want to take you guys through a quick kind of summary of how do we actually build effective agents. And we'll continue with the stack analogy here. Obviously, at the bottom is the most foundational layer of any agent, which is a good model, and Sonnet and Opus, as you know, for Claude. The next step is where it starts to get more interesting. This is where, the way we think about it is we want to provide building blocks and a layer to basically allow you to have reusable components to build on top of, which we call the agentic harness. So the first set of things here is tools. These are things like MCP, file system, and the purpose here is basically to let Claude exit out of just the LLM, exit out of its box, and be able to discover things outside using MCP, and maybe effect changes in the outside world, again, using MCP. We're using a file system, read and write files, for memory, for example. Now, once you have access to these tools, you can build the most basic agent by literally just writing a simple loop, which is a bunch of tool calls in a chain. Right? It could be as simple as a basic while loop, and there you go, you have an agent. The next thing here is prompts. The agent is kind of as good as the prompts you give it, right? And I'm not just talking about the initial prompt that you tell the agent. Obviously, you're going to give it some base context, what its goal is, what it's trying to achieve, but also the context that you give to its sub-agents, if it's a workflow running multiple agents, or kind of any context you might give it along the way so that it can steer itself towards achieving its goal that you told it to do.
Cool. And then next, once you kind of have those like foundational building blocks, right, you can start to kind of think about how do you introduce like more advanced capabilities that yield you meaningful results and returns on your evaluations. So after that, we're seeing an increasing pattern of agents where you give the model access to a file system. That has a variety of benefits, everything from the model being able to autonomously run bash commands and run code and have access to so many capabilities that a computer would have, as well as having access to a file system means you basically have access to memory capabilities where the model can actually autonomously write context to retrieve for future use, which is extraordinarily powerful. And most recently, we released something called skills. And we view skills as the way in which you can give models specialized domain expertise to accomplish tasks that the models might not be good at out of the box. Now, I wanted to say that like we could probably spend 30 minutes straight on skills, and there's another talk that should be coming out hopefully next week from one of my coworkers, Barry Zhang, on more details about skills. But to kind of sum it up really quickly for you, Skills is an open source framework that we released where you're able to basically give the model a collection of files, which would include like prompts, example scripts that it can use as tools, et cetera. And this is a really, really powerful, like just simple file structure that's very opinionated because skills give an agent, general capabilities that the model's not great at out of the box, knowledge of an organization's best practices, and we're really, really excited about how this kind of sets the foundation for procedural memory, where Claude can complete a task once and then write its own skills in the future, which is really, really exciting. And then once you have like a lot of those like most basic building blocks, you can start to add like all sorts of different enhancements, everything from sub-agents to context window compaction, to memory, to research, all these sorts of things. Now, If I work at Anthropic, which I do, I think I would think to myself, like, where have I seen this before, right? And I would say I've seen this before in exactly the same backend that we've created for Claude Code, right? And that kind of led us to an epiphany, which is that the actual backend, the agent harness around Claude Code is so powerful for things that are not just coding. So we have a lot of people at Anthropic, in our finance and legal and marketing teams who actually use Claude Code in their day-to-day for their own related tasks as well. So as a result, that kind of led us to build what we call the Claude Agent SDK. The idea here is this is the infrastructure on which we are actually building a lot of our new products and new features in the future that we want to give to all of you, such that like you're able to build more easily on top of Claude. And the idea is the Agent SDK is like an agent harness that we've designed around Claude that's generally pretty useful and well, and there's a very tight product research feedback loop to kind of improve the harness and the models against it. So the way we see it is like building on top of the Claude Agent SDK means that you're building on the same infrastructure that Anthropic is using for their own products. And secondly, you don't have to focus on the same infrastructure that all of your competitors might be focusing a lot of their time on. You should be focusing more on where you can actually differentiate, right? The actual user experience, the domain workflows that actually are going to differentiate your product from others. And our last thing before we leave you here today is just kind of thinking about like the rate of change in this industry. It's been quite astounding to see. I think the last like 2 years, Claude has moved from this sort of assistant category to an actual like collaborator that you're able to like delegate meaningful, complex work to. And we're really excited about like what'll happen as both the product infrastructure around the models as well as the models themselves continue to improve. Where we hope eventually in the future Claude is able to kind of pioneer these breakthrough solutions to challenging problems that it otherwise would not be able to out of the box. And the piece of advice I would leave you all here with today is think about some of the most successful companies that you've seen today in the startup ecosystem. Folks like Cursor, Windsurf, Lovable, right? They built a lot of their products back in like 2023, 2024 when these models were not that capable, and the products were like marginally useful, right? But what was really, really cool to see was that they effectively built a product that was actually much better when the models actually got better. So as the intelligence went exponential, so did their revenue, right? So we think that the most successful founders, agentic product developers, et cetera, are going to be the ones who actually are able to look into the future effectively and build the infrastructure they need now to leverage frontier intelligence. So that's like the last piece of advice we would leave for you all. And with that, we'll conclude. But thank you all for your time today.
Thanks, Tanveer and Utkarsh, for a quick overview of how to bring Claude's tools and features into AI products. We have time for one question.
Hey guys, thanks very much. That was a brilliant presentation. I'm curious about something that you called out when you were talking about moving from tool calling to like code generation and the code invokes the tools. It kind of seems to me like you're bucking the trend because it's sort of going backwards from where we were. And I think one of the problems that tool calling kind of solved was you got structured outputs that were consistent and you were able to reliably invoke those tools. Why does Anthropic feel like you want to sort of go back to what we were doing earlier? And what do you think is really the strength there and sort of what's your thought behind that?
Yeah. So the question, to summarize it really quickly, is with code generation, like the concern being that like the model kind of doesn't have enough rails around it and can do more than you ask for it, right, effectively, which is a fair concern. I think we have a philosophy internally at Anthropic, which is do the simple thing that works, which means you should build the simplest possible agent you can and then scale up complexity as it yields meaningful results in your evals, right? So in a lot of cases, like yes, tool calling is going to like work perfectly, meaning that you're going to be getting near 100% on a lot of your evals if you just implement it that way. And you should continue to do so if so. But we think there are a lot of use cases that will benefit meaningful like, results in evaluations in code generation especially. But to your kind of question on concerns, right? There's all sorts of different infrastructure choices you might make in terms of how do you actually enable the model to be able to like write and execute code. So I'll leave that to folks like Utkarsh and others to like kind of solve. But I'll more focus on the actual like model itself, which is, I would say that you should expect that the model should continue to get better, especially in the domain of instruction following, meaning that they'll become more malleable, such that they'll actually follow your instructions more precisely, et cetera. So if you basically tell the model like, that you only have access to XYZ packages, you can only do ABC things, right? It should adhere to that better in going forward into the future. But you can also sort of enforce those sorts of things deterministically by just like restricting the access it has in the actual code execution environment as well. So there are a couple like different levers you can pull, but I would argue that it's like a little combination of both infrastructure changes and how you prompt the model. And if you have anything else to add there.
I think you basically got it. Maybe the only thing I'll add is that this goes to kind of the reflection piece that Tanveer was talking about, where you can always go back and guide the model towards the goal you want. If it did more or less, just go give it more prompts and guide it.